This begins lesson 2.4, which is one solution, no solution, infinitely many. Whenever you simplify an equation, whenever you work through an equation, you get an answer. You get down to an answer where you can't go any further. If you get what we just did on all these other problems, and we find the solution, C equals, E equals, A equals, all of these are one solution problems. So if I gave you these problems that we've all done, and I said, is it one solution, infinitely many, or none? All of these problems we have completed in 2.1 and 2.2 have been one solution. Now there's two other options that you may be faced with. You may come to find a no solution or infinitely many. What a no solution is whenever you come down to, and you're solving both left side and right side, and you get down to where 2x plus 3 and 2x plus 5. This is one of a million examples. What that means is you had the same constants but different, same variables but different constants. I'm going to show you how this is a no solution. So say I get down to this last part and I'm trying to solve for x. So remember on my rules that my variables go to the left, so I'm going to try to get 2x to the left. So when I do that, I subtract 2x because what I do to one side, I do to the other. Well, that cancels out and gives me 0. Well, this cancels out and gives me 0. So I bring down what I have left, and that says 3 equals 5. Well, does 3 equal 5? It does not. So that is why it is considered a no solution. Now going on to infinitely many though. What this means is whenever you have the same variable and the same constant, this left side equals this right side. This is a no solution. I'm going to give you this example. If I was to make a quick t-chart, hold on, let me think how to do this. Not an XY chart. Let's just say I was to put in 1 for x. If I put in 1 for x, I would get If I put in 1 for x, I would get 2 times 1 plus 6 equals 2 times 1 plus 6. That would be 2 plus 6 equals 2 plus 6, which is 8 equals 8. Does that hold true? Yes. So 1 is a solution. Well, let's just say I put in 0 real quick. So that would be 2 times 0 plus 6, 2 times 0 plus 6, 0 times 2 is 0. So it's just 6 equals 2 times 0 is 0, 6. Does that hold true? Yes. If I put in 100 for x, if I put in 1,000,000 for x, if I put in any number for x, this left side will always equal this right side because they are the same exact expression. So that is why this has infinitely many solutions. Any solution will hold true. No matter what number you put in for x, this left side will always equal this right side. So if you get down to where the left side equals the right side identically, you have an infinite amount of solutions. To go ahead and show you what this would look like, say I got down to this point and you didn't notice it. So you follow on with those 5 rules, variables to the left. So I subtract 2x from one side, do it to the other. It cancels on this right side. Well, then it cancels on this left side. 6 equals 6. If you ever get something that a number equals a number and it holds true, it will always be infinitely many solutions. Alright, I'm going to do my first example on this. So you're still going to, even if the problem asks, fine if it's infinite, one solution, no solution, you cannot just guess on this. You still got to work it out like a regular equation because it could be a one solution. So going through my first step, I see parentheses. I've got to distribute. So that means this left side will just be completely written the same at the moment. Nothing's going on with this left side. Well, then I will distribute. 3 times 2w is 6w. And what I have to also multiply that 3 times 2 and 3 times 1.6, which is 4.8, and it would be a positive. So I've done my first step, which is distribute. Now I will go on to combine like terms. Are there any like terms? There's not on the right side, but I see two W's on this left side. So there's understood to be a 1 in front of that W. So when I combine it, that's just going to be 1W plus 5W, which is 6W. Now on this right side, bring down what I have. There's nothing to combine. And I will be moving on to my third step, which is variables on left. Well, I need to start looking. When you see that you have the same exact amount of variables, when I see that my constants are different, you should be thinking no solution. But we will go a step further if you don't recognize it. So variables on left. So I'll subtract 6W. Gone. What I did on one side, do to the other. Gone. So I bring down what I have. That's 4 equals 4.8. Which is not true, so that is a no solution. Then on the second example, see parentheses, we will be distributing. 4 will go multiply to the n and to the negative 2. So that will be 4n minus, keep that negative with it, minus 8. And you got to bring out what's on this outside parentheses as well. It will not be multiplied. It's outside the parentheses. We will not be multiplying that by 4. There's no parentheses, so I'm just going to continue to bring that down. The second step would be to combine like terms. I'm looking, oh, I had two constants. So negative 8, negative 1, I've got to combine that. When signs are the same, you can just type in your calculator. Negative 8 minus 1. Or signs are the same, you add those and keep the signs. So that would be 4n minus 9. Now I have to see, can I combine anything on this right side? And I can. I have a 5n and a negative 1n. That's what that's understood to be. So that's just like 5 minus 1. Which is 4, and you keep the constant with it, plus 9. Once again, if we notice, we have same variables, but different constants. That's going to be a no solution immediately, but let's continue to work through it. Say I got to get the rule. Next rule is variables on left. I'll subtract that 4n, gone. Subtract the 4n, gone. Bring down what I've not used. That's negative 9 equals 9. Which is not hold true. No solution. Alright, so that will complete this at the moment. I'll possibly maybe coming in with some more examples on 2.4 on one solution, no solution, infinitely many.